In this lesson, we'll be quickly discussing the remaining materials. We are basically done with the main materials, and I'll give you a general overview of the other materials like bump material, volume scatter material, VR matte material and converter, point particle material, VR scans, dark tree material, OSL material, GLSL map, and bake vector displacement. So let's open up our material editor. Right click and add a V-Ray bump material. The concept for this material is very simple. Using this material you can have bump mapping and normal mapping when using any material, or you can stack multiple normal or bump maps on one surface. Now let me quickly show you how it works. First you need to define your base material. In this case let's use a simple gray V-Ray MTL. Now that we have our base material, we need to define our bump or normal map in the bump map slot. Let's choose bitmap and select BW38 as the map. Now, as you can see from the material preview, we have added the bump mapping to our base material. And using the bump mount we can control the strength of the bump mapping, obviously. You might ask that we can do the same thing using the bump slot of our V-Ray MTL material. That is true, but we can stack up multiple bump effects using the bump material. To do so, let's create a new bump material. Connect the first bump material as the base material. And now we can layer up another bump effect on top of our existing one. In this case, let's use a simple procedural noise. For the time being, change the size of the noise to 25. Now if I open up a preview window for the second bump material and make it a bit bigger, you can see we have our bump mapping from the base material and then added the noise map as our bump map in the second bump material. Now we just need to assign our last material to our geometry and render the scene. So basically that's about bump material. Next we have volume scatter material or V-Ray scatter volume material. Let's add one to the active view here. This material is for subsurface scattering purposes, and its difference with fast SSS2 or skin material is that this material calculates subsurface scattering in a brute force fashion and gives unbiased results, and you can see its parameters are exactly the same as the fast SSS2 material but without any diffuse layer, and we have this extra bounces value here which controls the number of times a light ray can bounce inside the object. The way it is applied is very simple. You can apply it directly or as a base material for a V-Ray blend material. Let's create a new V-Ray blend material. Use the volume scatter material as the base material. Add a new V-Ray MTL. Change its diffuse color to black. Change the reflection color to a gray color with the value of 100, and change the refract color to white color with the value of 180. Let's change the reflection and refraction glossiness to 0.7 as well. Now use this material as the coat material. In the scatter volume material, change the scatter radius to 4. Let me hide the shader ball here, unhide the dragon and assign the blend material to it. And if we render the scene right now, the result would be render 0, 1. Okay, so that's about volume scatter material. Next we have our VR matte material. Let's add one to the active view. The V-Ray VR matte material loads and uses .VR matte materials that were exported from 3ds Max, Maya, Rhino, or SketchUp. It also provides access to the VR matte editor. In this case, I think because I'm using the educational version of V-Ray to record this course, I don't have access to the VR matte editor. As you can see, it's grayed out here. It just provides an interface to edit the material. It's very simple. So imagine you are working in V-Ray for 3ds Max and your colleague uses V-Ray for Maya, for example. You can simply convert your existing V-Ray material in the scene to VR matte format using VR matte converter and send the VR matte file to your colleague, and he or she can load that material using VR matte material. Before loading VR matte files in the VR matte material, let's first learn how to convert our materials to VR matte files. First, let me hide the dragon in the scene and unhide the shader ball. We have this reflective material in the active view. Let's assign it to the shader ball. Also, it has this map that controls the reflection glassiness. Now, if we render the scene right now, the result would be render 02. Now, if I want to convert this material to a VR matte file, I need to go to the Tools menu and select V-Ray VR matte converter. We have a bunch of options here. Load library, press this button to load a material library file that was previously exported from 3ds Max. You have use current lib, press this button to use the currently material library from the scene. Convert lib to .VR matte, press this button to convert each material in the library to a separate VR matte file, and convert lib in one .VR matte, press this button to convert all the materials in the library to a single .VR matte file. And pick and convert material, you can select a single material to be converted to a .VR matte file using this button, and convert scene materials to .VR matte. Using this one, you can convert all materials in the scene to separate VR matte files. In this case, let's choose pick and convert material. From the scene materials, select glossy, which is the name of our currently applied material to the shader ball, and press OK twice. Now you need to define where you want to save the .VR matte. I'm gonna save it in the material library folder in the project files for this course, and press OK. Now if I close the VR matte converter and get back to the active view and select the VR matte material that we created earlier, I can load the .VR matte file that we just exported. You can see we have this glossy folder that was created based on the name of the material, and if you go inside it, we have glossy.VR matte file. Let's open this file, and as you can see from the material preview, the material has been loaded correctly. Now I can assign this material to the shader ball again, and if I render the scene, the result would be render 03, which is the same render as our previous render when we use the actual material. I think we just have some problem with the reflection caustics. Next we have V-Ray point particle material, and this is for rendering particles from Alembic or VR mesh files when the particle render mode in the V-Ray proxy object is set to point. Let's close this windows here and load some particles using V-Ray proxy. Let's create a V-Ray proxy from V-Ray toolbar. In the proxies folder of the project file, there is this particle.abc file, which is an Alembic file. And let's load this. And if I move through the timeline, we get this simple particle sim. Let me just rotate, move, and scale the particles a bit. In the proxy settings and particles section, change the render mode to point. Also, let's hide the shader ball and move the camera a bit so we can see more particles. Now let's create a point particle material and assign it to the particles. Change the diffuse color to a green color like 10, 128, and 79. Now if we render the scene, the result would be render 04. Maybe the camera position is a bit different, but you can see very close. Instead of a color, we can use a texture in the diffuse map slot to control the color of the particles. We have used particle color. If the particles have a color channel, the color will be taken from the particles. And we have phase function, which how the light rays basically scatter from the particles. And it works like the phase function parameters in the fast SSS2 material. Okay, let me hide the particles and unhide the shader ball and move the camera as well to its previous position. Let's get back to the material editor again. Next we have VR scans or VR scans material. The VR scanned MTL material allows the rendering of scanned BRDF material data stored in .VR scans file. These files are produced by Chaos Group's own internal material scanner and accompanying material creator software. Scanned materials captures the appearance of an actual physical material sample that has been scanned with special scanner hardware. Obviously, you need to buy the product in the Chaos Group website or vrscans.com and download the scanned material and use them in your project. And they are super duper realistic, as you can see. I'll show you this page from Chaos Group websites. And if you have the license for VR scans, you can load the VR scan files using the VR scan material and assign it to your project and object. Next, we have V-Ray dark tree material or V-Ray symbiont MTL. Let's add one to the active view. The V-Ray dark tree material enables procedural dark tree shaders to be rendered with V-Ray, and if you go to darksim.com, you can download some dark tree shaders. I've saved some of those dark tree shaders in the material libraries folder of the project files for this course. Let's go to the metal folder and make sure we are looking at all the files, and let's select metal rusty steel.dsts. We have some self-explanatory parameters to adjust the material, and this is a procedural material, so you don't need any UV mapping on your mesh. In this case, let me just set the bump scale to 0.2 and assign the material to the shader ball. And if we render the scene, the result would be render 05. Get this fairly realistic rusty material very easily. Easy work. Next, we have V-Ray OSL material or Open Shading Language OSL. The V-Ray OSL MTL material can be used to load OSL shader code files .osl or OSL object code files .oso and render them directly with V-Ray. You can find shader codes in .osl or .oso formats on the web and load them here, assign the material to your object and render your scene. We have V-Ray GLSL map. This map can be used to load GLSL shaders and render them in V-Ray, and you can find these shaders also on the web. You can go to the V-Ray's guide and learn more about these external shaders because we really can't cover them in detail here in this introductory course. And finally, we have bake vector displacement, or V-Ray vector displacement bake. And if I quote V-Ray's guide, V-Ray vector displacement bake is a utility material that, when used along with texture baking, allows you to generate displacement maps for vector displacement. The workflow requires that you have a low poly base geometry and a high poly target geometry. You can then generate a map that, when used with vector displacement, turns the base geometry into the high poly target geometry. To do that, first we assign the V-Ray vector displacement baked material to the base geometry, and in the material setting we specify the target geometry. Next, using texture baking, we bake a V-Ray complete map for the base geometry. This generates a vector displacement texture that we can use with the V-Ray displacement mode and vector displacement to turn this base geometry into the target geometry. There is a very detailed and long project-based tutorial about texture baking with V-Ray, and V-Ray's you can find that in V-Ray's guide, that I recommend you to check it out. It's very useful. So I think that is enough for the materials, and in the next lesson of this section we'll be taking a look at some of the available specific and useful V-Ray maps. In this lesson we'll learn about bump material, volume scatter material, VR matte material and converter, point particle material, VR scans, dark tree material, OSL material, GLSL map, and bake vector displacement. A very general overview. I will see you in the next lesson.